Good morning, students. Today I am continuing with chapter number 6, and the name of the chapter is Application of Derivatives. It is one of the interesting chapter related with differentiation. So basically this chapter play a very vital role in the field of engineering, science, social science and many other fields. In this chapter we will discuss about rate of change of quantities, then increasing and decreasing functions, equation of tangent and normal, and then approximation, and last one we will continue with very important concept, that is maxima and minima. So basically in these 5 subtopics I will focus mainly on second, third and fifth one, and I will give only the brief summary about first and fourth, because these 2 points this time not in our course in session 2020 and 21. So these 2 points are already removed from the course. So mainly in this chapter I will focus second, third and fifth point, and I will give the little bit, or we will do the little bit discussion about the first and fourth point. So first we will start from the concept, that is the first point, that is rate of change of quantities. So under this heading, rate of change of quantities, if I am saying d by dt of s, where s is displacement, or you can say distance, then what is the meaning of this? So we know this thing, velocity is d by dt of s. Then we can say rate of change in distance with respect to time t. If I am saying for y equals to fx, then what is the meaning of dy by dx? It means rate of change in variable y with respect to variable x, and it is also denoted by f dash x. If I am saying dy by dx at x equals to x0, it means rate of change, d by dx is denoted by rate of change. So we can say rate of change in variable y with respect to variable x at x equals to x0, and it can also be denoted by f dash x0. So what is the actual meaning of this? So as per this concept, we can say if we are taking two functions, x equals to ft and y equals to gt, then we can say by chain rule dy by dx equals to dy by dt upon dx upon dt, where dx upon dt is not equals to 0. So it means what? Rate of change in variable y with respect to x can be calculated by rate of change in variable y and x with respect to t. So we will not discuss much more about this concept. As I told earlier, I will give only the brief discussion or brief summary of this concept. So this is the way of solving the question which is related with rate of change. Now I am continuing with the next concept, and the next concept is increasing and decreasing function. So if I am taking here one function as fx equals to x square, where x belongs to real number, then how can we will plot the graph for such type of the function? So as you see here, two tables are there. So the first table, that is values right to origin. It means right to origin if we are taking different value of x, because right to origin, this is related with the positive x-axis, so that we will take the positive value. We will start from 0, half, 1, 3 by 2 and 2, and when we will put these values in the given function, we will get different value of y. After this, if we come to here, it is written here values left to origin. If we go to left to origin, it means we will take x dash o, which is the negative x-axis, and if we take the negative value of x, and when we will put here, so these are the value we will get, and when we plot the graph, it look like this, and this is the graph of parabola. It means when we go from left to origin, the graph is decreasing, and when we go from right to origin, graph is increasing. It means we can say on behalf of these values, if function is increasing when x is greater than 0, and when function is decreasing when x is less than 0. So with the help of this graph, we will easily tell when function is increasing and when function is decreasing. Now I am continuing with the definition of increasing function and decreasing function. So how can we will define the definition of increasing function? Let I be an open interval contained in the domain of f, and here f is real valued function, then f is said to be increasing on I if x1 is less than x2, and it implies fx1 less than equals to fx2 for every x1 x2 belongs to I. Okay, and if we continue with the strictly increasing on I if x1 less than x2, which implies fx1 less than fx2 for every x1 x2 belongs to I. So this is the definition of increasing function. So how can we will give the definition for decreasing function? So the definition of decreasing function is, let I be an open interval contained in the domain of real valued function f, then f is said to be decreasing. We will write here decreasing on I if x1 less than x2, which implies fx1, note the symbol will change, and here we will write greater than equals to, other things are same, and here we will write strictly decreasing on I if x1 less than x2 and fx1 is greater than fx2. So these are the definition of increasing function and decreasing function. Now I will make some graph related with increasing function or decreasing function, so the concept or definition of these functions will more clear to all of you. Now the graphical representation of these functions are graphical representation of increasing function and decreasing function. So how can we will draw the graph? How can we say which graph is related with increasing or which graph is related with strictly increasing? So I am continuing with some graph. So first we will continue with the x-axis and x2 x dash and y2 y dash. Okay, so if I am continuing with this is the graph related with increasing function, right? So what about strictly increasing function? How can we will denote the graph? Again we will go with x2 x dash and y2 or y0 y dash. X0 x dash is horizontal axis and y0 y dash is the vertical axis. So if this type of graph is related with increasing function, then for strictly increasing function we can say graph look like this. This is strictly increasing. So this is the graph related with strictly increasing function. Okay, now I am continuing with the decreasing function and strictly decreasing function. So the graph of decreasing function is, again we will continue with this first, x o x dash, y o y dash. So for the graph of decreasing function is look like this. This is the function of decreasing, or this is the graph of decreasing function. Then how can we will plot the graph for strictly decreasing function? So strictly decreasing function look like we can say this type. This is strictly decreasing. So this is the graph related with strictly decreasing function. So when we can say कि the function is neither increasing or neither decreasing and it groups like it's a graph like, how can we will draw the graph of the function which is neither increasing or neither decreasing? So again, if we continue with the coordinate axis which will intersect at point O, then we can say it look like this. So this is the graph related with neither increasing nor decreasing function. So with the help of these graphs we will easily identify which type of graph is related with increasing function or strictly increasing function, or which type of the graph related with decreasing or strictly decreasing, and this type of graph is related with neither increasing or nor decreasing function. Now after graphical representation of the function, I am continuing with the intervals, in which interval the given function is increasing or decreasing. So let f be continuous in closed interval a comma b and differentiable in open interval a comma b. Then we can say if f dash x is greater than 0 for each x belongs to a comma b, then we can say f is increasing in closed interval a comma b and f is strictly increasing in open interval a comma b. But if f dash x is less than 0, then we can say f is decreasing in closed interval a comma b and it is strictly decreasing in open interval a comma b for each x belongs to open interval a comma b. The third point is if f dash x equals to 0 for each x belongs to a comma b, then we can say f is a constant function, and if f dash x equals to 0, after that we will calculate the value of x, and these values of x are known as critical points. Now I am continuing with one problem, and the problem is show that the function given by fx equals to 7x minus 3 is strictly increasing on r. So how can we will solve such type of the problem? Let x1 comma x2 both are the member of r. Here r is real number. So if x1 is less than x2, then we can say 7x1 is also less than 7x2. We will multiply here both the side by 7. Now we will subtract both the side 3. So it can be written as this. And 7x1 minus 3 as per the given function, if we will put here x1, we can say, or you see here, if fx equals to 7x minus 3, then we can say the value of fx1 is 7x minus 3 and the value of fx2 is 7x2 minus 3. So when we will put here, we will get fx1 is less than fx2. It means as per the definition of increasing function, we can say if x1 is less than x2, then fx1 is less than fx2 for every x1 x2 belongs to r. Therefore given function is strictly increasing on r. It means such type of the function is fulfill the condition related with strictly increasing. So with the help of this procedure or with the help of this definition, we will easily define if the given function is strictly increasing on r or not. Now I am continuing with the second problem, and the second problem is find the intervals in which the function f given by fx equals to 4x cube minus 6x square minus 72x plus 30 is strictly increasing and strictly decreasing. So basically in this question we have to identify the intervals in which the given function is strictly increasing and strictly decreasing. This question is, or that type of question is very important, you can say. So how can we will identify the intervals and how can we will show yes, in this interval this function is strictly increasing or strictly decreasing. So how can we will start, how can we will solve such type of the problem? So first we will write given fx equals to 4x cube minus 6x square minus 72x plus 30. So first we will calculate differentiation, because strictly increasing and strictly decreasing both are related with the differentiation first. So when we will solve it, we will get 12x square minus 12x minus 72, and here we will take common 12. So x square minus x minus 6, it is the quadratic expression. So we will go with the factors first. We will continue with the concept of splitting the middle term. So how can we will factorize it? It can be written as x square minus 3x plus 2x minus 6. Or in first two terms, we will take common x. So it can be written as x minus 3 plus 2, x minus 3. And here we will write f dash x as 12, x minus 3, x plus 2. So after calculating f dash x, how can we will identify the value of x, because we have to continue with the intervals. So what we will do, we will put f dash x equals to 0. So 12 x minus 3 x plus 2 equals to 0. So when we will solve it, we will get x equals to minus 2 and 3. So after this we will draw a number line. This is minus infinity to plus infinity, and this is minus 2 to 3. So intervals are minus infinity to minus 2, minus 2 to 3, and 3 to positive infinity. Now we have to tell in which intervals the given function is strictly increasing or in which interval it is strictly decreasing. So how can we will show it? So for this we will make a table. With the help of that table we will easily identify yes, in particular interval the given function is strictly increasing or strictly decreasing. So we will continue with the table. Then we will make the column, and here we will write intervals. So intervals are minus infinity to minus 2, minus 2 to 3, and 3 to infinity. And here we will write the factors, that is x minus 3, x plus 2. We will make one more column. So when we will make one more column, so here what we will write, here we will write the value of f dash x, which is equivalent to 12 x minus 3 x plus 2. Okay, now we have to calculate in which interval the given function is strictly increasing or in which interval it is strictly decreasing. So what we will do, we will take any value between minus infinity to minus 2. Let's we take minus 3, which is lie between in this interval. So if we put minus 3 as a value of x, so minus 3 and minus 3, it becomes negative, right? So minus 3 plus 2, when we will solve it, we will get minus 1. Again it becomes negative. Now we will put the value of x minus 3, or we can say we will put the symbol of x minus 3 and symbol of x plus 2 in this function f dash x. So what we will get, 12 minus into minus, it becomes plus. So we will get positive symbol for f dash x if we are taking this interval. Now I am taking one more value between minus 2 to 3. We will take minus 1 or 0 or 1 or 2 because it is open interval. So if I am taking plus 1, so 1 minus 3 becomes minus 2, which is negative. 1 plus 2, it is 3, which is positive. And when we will put the symbol of x minus 3 and x plus 2 in f dash x, then what will come? 12 multiplied by minus, it becomes minus 12. Minus 12 multiplied by positive, it becomes again minus. So we will get minus sign here. Now same procedure we will apply here, 3 comma infinity. Now I am taking the value of x as 4 because 4 is lie between 3 to infinity. So 4 minus 3 becomes positive 1. So it means we will write here positive. 4 plus 2 is 6. Again it is positive. So 12 is already positive, x minus 3 is positive, x plus 2 is already positive. So we can say it becomes positive. So it means we can say for this interval, the given function is strictly increasing. Same for this. These are positive symbol. But for this, we can say the given function is strictly decreasing. At last we can say therefore in intervals minus infinity to minus 2 and 3 comma infinity, the fx is strictly increasing, and for interval minus 2 to 3, the given function fx is strictly decreasing. So this is the way of solving the question which is related with interval. So with the help of this procedure, we will easily show in which intervals the given function is strictly increasing or in which interval it is strictly decreasing. Now I am continuing with the next concept, that is tangents and normals. So what is the meaning of tangents and normals? So if we draw a curve that is equivalent to y equals to fx, So we can say this line denote tangent, and this is the line related with normal. If this intersection point is related with A, then we can say normal line at point A, and this is tangent line at point A. Okay, so how can we will show the equation of tangent and equation of normal? So before that, we will go to in one chapter related with the 11th class, that is straight line. So equation of straight line passing through a point x0 y0 having finite slope m is given by y minus y0 m x minus x0. So in that case we can say slope of tangent to the curve y equals to fx at the point x0 y0 is given by dy by dx passing through x0 y0, and it can also be denoted as f dash x0. So this is the slope of tangent. So how can we will denote the equation of tangent? So we can say equation of tangent to the curve y equals to fx at the point x0 y0 is given by y minus y0 equals to f dash x0 x minus x0. So here we will put the slope as slope of tangent, and the value of slope of tangent is f dash x0. So this is the equation of tangent, right? Now how can we will identify the equation of normal? So after this we can say, as per this diagram, this normal line is perpendicular on this tangent line. It means slope of normal to the curve y equals to fx at the point x0 y0 is given by minus 1 upon f dash x0, because we know very well that whenever two lines are perpendicular, then m1 m2 equals to minus 1, so that we can say m2 equals to minus 1 upon m1. Same concept we will apply here. So if the slope of normal to the curve y equals to fx at the point x0 y0 is minus 1 upon f dash x0, then how can we will show the equation of normal? So we can say equation of normal to the curve y equals to fx for the point x0 y0 is y minus y0, and this is equals to minus 1 upon f dash x0 x minus x0. It can also be written as y minus y0 multiplied by f dash x0 equals to minus x minus x0. It means we can say equation of normal to the curve y equals to fx at the point x0 y0 is given by this. So this is the equation of normal. So with the help of equation of tangent and normal, we will solve so many questions which are related with the tangent and normal. So the slope of tangent, this is equals to dy by dx, and we can say it is also equals to tan theta. It means tangent line to the curve y equals to fx making an angle theta with x axis in the positive direction. This is the meaning of this concept. I repeat it again. It means tangent line to the curve y equals to fx making an angle theta with x axis in the positive direction. Now we will continue with some particular cases. In particular cases, we can say if the slope of tangent, it means if tan theta equals to 0, then we can say tangent line to the curve y equals to fx is parallel to the x-axis. It means equation of tangent is given by y minus y0 equals to 0, x minus x0, and when we will solve it, it becomes y equals to y0 at the point x0, y0. So this is the concept. When slope of the tangent is equals to 0, then we can say equation of tangent is parallel to the x-axis. Now we will take the second concept. If the slope of tangent, or we can say if tan theta equals to tan pi by 2, or we can say if we are taking theta as pi by 2, so it becomes infinity. In this case we can say tangent line is perpendicular to the x-axis, or we can say tangent line is parallel to y-axis. In this case, equation of tangent is given by y minus y0 equals to infinity x minus x0, and when we will solve it, we will get x equals to x0. It means when theta is pi by 2, the equation of tangent line at the point x0, y0 is given by x equals to x0. So these two conditions are related with the particular case, and it is related with slope of tangent. Now I am continuing with one problem related with tangent and normal, or you can say related with equation of tangent and equation of normal, and the question is find the equations of the tangent and normal to the curve at point 1, 1. So how can we will solve such type of problem? So first we will write down, we know that equation of tangent is y minus y0 equals to dy by dx at the point or passing through the point x0, y0, x minus x0. We will indicate this as equation number first, and we also know that equation of normal is y minus y0 equals to 1 minus dy by dx passing through the point x0, y0, x minus x0. This is equation number second. So it means what we have to calculate? We have to calculate derivative at the point x0, y0. So this time the equation of curve is x raised to the power 2 upon 3 plus y raised to the power 2 upon 3 equals to 2, and point is 1, 1. So how can we will solve it? How can we will find the value of equation of tangent and equation of normal? So we will continue with this. So after this we will solve the derivative part with the help of given equation. So what is given to us? We have to given x raised to the power 2 upon 3 plus y raised to the power 2 upon 3 equals to 2. So when we will differentiate it, so it becomes 2 upon 3 x raised to the power minus 1 upon 3 plus 2 upon 3 y raised to the power minus 1 upon 3 dy by dx, and the differentiation of right hand side is 0. We will take common 2 upon 3. It means it can be written as x minus 1 upon 3 plus y minus 1 upon 3 dy by dx. This is equals to 0. So we can say the value of dy by dx, this is equals to minus x raised to the power minus 1 upon 3 upon y raised to the power minus 1 upon 3, and it can be written as y upon x and the whole power is 1 upon 3. So this is the derivative part of this given equation. Now after this what we will do, this dy by dx is passing through the given point 1 comma 1. So when we will put here, we will get minus 1 upon 1 in cube root, it becomes minus 1. So this is the derivative part, and this is your derivative part passing through point 1 comma 1, or we can say it is the slope. After this we will put all these values in equation number first and second. So we can say from equation first, equation of tangent is y minus y0, and this is the value of x0, this is the value of y0. So value of y0 is 1 and slope is minus 1, x minus again the value of x0 is 1. So we will get y minus 1 equals to minus x plus 1, and when we will solve it we will get x plus y minus 2 equals to 0. So this is equation of tangent, this is the one part. And from equation number second we can say y minus 1 equals to minus 1 upon minus 1 x minus 1. Now we will solve it, y minus 1 equals to x minus 1. So we can say x plus y equals to 0. So this equation is related with equation of tangent, and this equation is related with equation of normals. So whenever such type of problem is given to us, first we will indicate the formula, or as per the requirement of the formula we will calculate first derivative, and then we will calculate slope at the point 1 comma 1, and after that we will put the value and we will easily get the equations of normal and equation of tangent. Now I am continuing with the next question. Find the equation of tangent to the curve given by x equals to a sine cube t, comma y equals to b cos cube t at a point where t equals to pi by 2. So how can we will solve such type of question? So as you see in this question, we have to calculate equation of tangent, and this time the value of x and y both are given. It means it is related with the parametric form. If the value of x and y both are given with one another parameter, that is t, then we can say that type of question is related with the parametric form, and the concept of parametric form is related with our chapter number 5. So how can we will solve such type of problem? So first we will write down, we know that equation of tangent is y minus y0 dy by dx passing through the point x0 comma y0 x minus x0. It means in this question we have to calculate the dy by dx at x0 and y0, but this time point is related with t equals to pi by 2. So how can we will solve such type of problem? First we will indicate this equation as equation number first. So with the given value of x and y, first we will calculate dy by dx. So what is given to us? We have to given x equals to a sine cube t. It means dx upon dt. We will solve here. So it becomes 3a sine square t, and the differentiation of sine t is cos t. After this, y is given as b cos cube t. So the value of dy by dt, it becomes 3b cos square t, and the differentiation of cos t is minus sine t. So how can we will calculate dy by dx? What we will do? We will divide dy by dt by ds upon dt, and when we will do it, what we will get? 3b cos square t, or in bracket we will write down minus sin t upon 3a sin square t cos t. It means 3 and 3 cancel. So what we will get? So the value of dy by dx, this is equals to cos t and cos t also cancel, and sin t also cancel. It means we will get b cos t upon a sin t, which is equivalent to b upon a cot t. Okay, and it is given here at a point where t equals to pi by 2. It means the value of dy by dx at t equals to pi by 2, because this right hand side is related with the variable t. So when we will solve it, b upon a cot pi by 2. So what is the value of cot pi by 2? We can say cot pi by 2 is equivalent to cot pi by 2 is equivalent to 1. It is 1 upon 10 pi by 2, and 10 pi by 2 is infinity. So what we will get? We will get, you can say, cot pi by 2 equals to 1 upon 10 pi by 2. So when we will put the value 1 upon infinity, so we will get 0. So we will write here 0, and we will get dy by dx at t equals to pi by 2 as 0. So after this, now we will calculate the value of x0 and y0 for equation number first. So x equals to a sin cube t is given to us. So again we will put the value of t here, that is pi by 2, and it can be written as a sin pi by 2 whole cube, and sin pi by 2 is 1. So we will get the value of x is a, and what is the value of y? We will calculate from here. B cos cube, put the value of t, that is pi by 2, and it can be written as whole cube of cos pi by 2. Cos pi by 2 is 0, so it becomes 0. It means we can say, so the point is a comma 0. So this is the differentiation, or you can say slope, and this is the point. So put all these values in equation number first. So from equation first, we can say y minus y0, the value of y0 is 0, and the value of slope, that is also 0, x minus a, the value of x0 is a. So when we will solve it, we will get y equals to 0. It means this is the equation of tangent when such type of curve is given at the point t equals to pi by 2. Now I am continuing with the concept, that is approximation. So if a function y equals to fx, then we can say delta x is a small increment in x, and delta y is a increment in y corresponding to the increment in x. In that case, delta y is given by f x plus delta x minus fx, or we can say dy is given by f dash x dx, or it can also be written as delta y, or you can say it can also be written as dy equals to dy by dx into delta x. So this is the concept related with approximation. With the help of this concept, we will solve the problems which is related with approximation.